Welcome everybody. This is our third class or third lecture in NEET previous year questions for chapter Oscillation of class 11th. Before this, we have made two videos in this series and all of those videos are available on our YouTube channel. Again, name of channel is Point Basics and there is a dedicated playlist for these type of videos. So you can go to our channel and in playlist section you can find all those videos. We have also started similar series for JE previous year's questions, so you can also go to playlist section and find those videos. And if you find these videos useful, then do like these videos, share them as much as possible, and subscribe to our channel. Your like, share, and subscribe help us a lot. Also, if you want to support us financially, then you can scan any of these QR codes. With your donations, we will be able to continue and keep on bringing these videos and these better good content for you in future. So with this, let's start today's video. I think we have completed up to question number 30 or something. Yes, this was the last question which we covered up to 29, I think, or 30 we have already covered. So today we are going to start with 31. So here it is mentioned, a spring is stretched by 5 centimeter by a force of 10 Newton. So force of 10 Newton produces a stretch of 5 centimeter. The period of oscillation when mass of 2 kg is suspended from it. So for a spring, we know that omega is given by under root k by m. So we have to find the value of k that is related to spring, and we have given mass already given, so we can put the values and can easily solve it. So now going for spring f is given equal to kx, exactly to be minus kx, but we will be only dealing with magnitude here. So force is 10, k we will find out, and x is 5 centimeter or 5 into 10 raised to power minus 2. So from this, k will comes out to be 2 into 10 raised to power 2 Newton per meter. We have the value of k, we have the mass, so omega comes out to be 2 into 10 raised to power 2 divided by mass is 2 kg here. So it comes out to be 10. So omega is equal to 10 and omega is equal to 2 pi by t. From this we get 5, and time period, or we can say we don't cut it, we will use 10. Time period will be 2 pi by 10, and we know 2 pi is 6.28 divided by 10 will be 0.628 seconds. That's why we didn't cut 10 from with the help of 2. So option D will be the right answer. Next question. A spring of force constant K is cut into length of ratio 1 ratio 2 ratio 3. If they are connected in series, the new force constant is K dash. If they are connected in parallel, the force constant is K double dash. So we have to find out K dash ratio K double dash. So there will be we can say three steps in this question. First, after cutting the lengths, we have to find out their new value of k for each part. Then we will, in second step, we will add them in series, do series analysis, and then we do parallel analysis, and then we take the ratio. So for this, let's slide it slightly. Okay. Now we know that for a spring, that kx, or we can say k into length, is constant. Okay, so as we have divided length into 1 ratio 2 ratio 3 parts, so L1 will be, if original length is L, it will be L divided by 3 plus 2 plus 1 6. L2 will be twice of L by 6 and L3 will be thrice of L by 6. These are the new lengths, and again, as KL is constant, so for first part, K will be new K will be K1 into L1 should be equal to KL. From this we can find out that K1 into L1 is L by 6 equal to K into L, and L get cancelled. From this, K1 is equal to 6 times of K. Similarly, we can find out that K2 will be here we have in K2 we will be having 2L1, so it will be 2 and it will become 3K, and K3 will become 2K. Basically, we will use KL is constant equal to KN1 KL, or similarly K2 L2 is equal to KL, and K3 L3 is equal to KL. Using this, we get values of K1, K2, K3 like this. Now, now we have to do their series and parallel combination. Now, when we add them in series, so when they are added in series, then they act as a resistance in parallel, so they will be added as and series is given by K dash, so K dash will be equals to 1 by 6K plus 1 by 3K plus 1 by 2K. Their LCM will be 6K, so 1 plus 2 plus 3, and this will be 6 by 6K, so 1 by K, or K dash is equal to K. So when we add them in series, their combination just act as a normal spring, or yes, the normal spring which from which we have cut those parts. So if we add them or we join them again back together, so it should behave like a normal spring, and which it is showing. Now when they are in parallel, K dash will be just their linear combination or algebraic addition. So 6K plus 3K plus 2K, so it will be give us 9 to 11K. And now K dash by K double dash will be K by 11K, so this will give us 1 by 11. That option C is the right answer. Let us move to next question. A body of mass m is attached to the lower end of a spring whose end is fixed. The spring has negligible mass. When the mass is slightly pulled down and released, it oscillates with time period 3 seconds. So we already know for a spring omega, it is under root k by m. When the mass is increased by 1 kg, time period becomes 5 seconds. So the value of m, so we have to find out value of m. Okay. So we know for a spring, omega is given by under root k by m, and omega is 2 pi by t is equal to k by m, and from this time period comes out to be 2 pi under root m by k. So we can easily say that the time period is proportional to root of mass. Now when mass is m, time period is 3, so 3 is proportional to m. Now when mass is time period is 5 seconds, mass becomes m plus 1, so 5 is proportional to m plus 1. We can divide both of these equations, so 3 by 5 is equal to under root m by m plus 1, squaring both sides, 9 by 25 is equal to m by m plus 1. 9m plus 9 is equal to 25m, and subtracting 9 is equal to 16m, and m is equal to 9 by 16. Option D is the right answer. Next question. Time period of oscillation of mass m suspended from a spring of negligible mass is t if along with another mass m is also suspended, time period of the oscillation will be. So we have just solved, and we just find out that the time period is proportional to under root of mass suspended from the spring. Here it is. We just found out the value. So now if another mass m is also suspended, so t dash suppose is the new time period. Now total mass is 2m. So we have to find the ratio. So t dash by t is equal to 2m by m get cancelled. T dash by t is equal to root 2, and t dash is the new time period is equal to root 2 times t. So option D. Next question. So a mass of 2 kg is put on flat pan attached to a vertical spring on the ground as shown in the figure. The mass of the spring and the pan is negligible. So spring and pan does not have any mass. When pressed slightly and released, the mass executes SHM. Spring constant is given. What should be the minimum amplitude of the motion so that the mass gets detached from the pan? Now here, when the spring is oscillating, so when spring is oscillating from its mean position, then it has directions of acceleration. Let me show you. Suppose this is the equilibrium position of the spring. Now spring can be compressed from this position and spring can be stretched from this position. This is our, you can say, pan. This is our pan in both situations. This is mean position. While oscillating, it will go downward from the mean position and it will go upward from the mean position. While it is downward from its mean position, then its acceleration is towards the mean position. So here acceleration is upward, and value of acceleration is for SHM is omega square x, and maximum value will be omega square x when x is equal to amplitude, so omega square a. And in this scenario also, here acceleration will again towards center, and again acceleration will be omega square a, maximum value of acceleration. So when spring in this position and its downward acceleration is omega square a, and there is a mass placed on this pan, that is mass m, its downward acceleration, because this mass is not attached to this pan, it is just placed on it, so its downward acceleration can be maximum will be z. Its maximum acceleration can be g. For this pan, maximum acceleration is omega square a. So if omega square a for this pan or this spring exceeds acceleration of mass m, that is g, then this pan will go faster downward as compared to this mass, and mass will get detached from this pan. So we have to just solve this equation that omega square a is greater than g, and then the situation that mass gets detached from the pan is satisfied. So for this, we have to find amplitude, omega, and all other things. I think, yes, we have to find the amplitude. What should be the minimum amplitude? We have to solve for amplitude. We have to calculate omega here. The value of g we already know, and it is given 10. So for a spring, omega is given by under root k by m. K is 200 and m is 2. So omega comes out to be 10. Omega square comes out to be 100. A is greater than 10, or A is greater than 10 by 100, and this comes out to be that A is greater than 10 centimeter or greater than equals to. Even when you can say even when omega square A is equal to g, so both of them will be moving downward with the same acceleration, so we can take them as detached because here normal reaction will be 0. So here we can say greater than equal to sign will come, so A is greater than equal to 10 centimeter, or option A, that because we have to find the minimum value, so option A satisfy that minimum amplitude should be 10, or any amplitude greater than 10 centimeter will result in detachment of the mass from the pan. Moving to next question. Time period of mass suspended from a spring is T. If the spring is cut into four equal parts of same mass is suspended from one of these parts, then the new time period will be. So we have to find new time period. Now when you cut spring into four equal parts, then new k dash for the spring will be 4 times of the old one, and we already know that time period is given by under root 2 pi m by k. This is the original time period, and the new time period will be, because the part which we have cut from the original spring, we are hanging same mass with them, so mass is again m, and k comes out to be 4k. K dash means comes out to be 4k, so 1 by 4 comes out in the form of 1 by 2 as under root is there, and this is m by k. This is known as, this will be equal to t, so answer is t by 2. Option C is the right answer. And how we solve this, that can be found out on here. We will use spring constant, that k into l is constant. Here length is l by 4, because we cut spring into four equal parts, so l dash is equal to l by 4, or means k dash into l dash is equal to k into l. K dash into l by 4 is equal to k into l, else get cancelled. K dash is equal to 4 times of k. Moving to next question. A particle moving along x-axis execute SHM. Force acting on it given by. So we have to find out the force. Now for SHM, we know that force is proportional to negative of displacement, or force can be written as minus kx. So SHM must satisfy this equation. Here these two and these three, option B, C, D does not satisfy this equation, because here force is written as A into cos into A into exponential, and here we have positive sign. Only option A fits the equation, because here k is constant, so we can multiply it with another constant A into k dash x. So this also satisfies the equation, because we have a negative sign and displacement is there. Here x is denoting the displacement. Moving to next question. Particle executes simple harmonic motion, amplitude A, same potential and kinetic energies at displacement. Okay, so we have to find out the value of displacement where kinetic and potential energies are equal. We know already the equation or formulas for kinetic and potential energy. So potential energy of a SHM is given by half k x square, also, and kinetic energy is given by half m v square, where v is given by, we know that v is equal to omega a square minus x square, where a is the maximum amplitude, so it will be omega square and a square minus x square, where x is the displacement from the mean position, and we can also substitute m uh, or k depending upon whatever we are using. So as given that both of energies are equal, so potential energy is equal to kinetic energy, so half kx square is equal to half m omega square into a square minus x square. Now we will substitute k. How? We know that for a simple harmonic motion, omega is given by under root k by m. So from this, omega square into m is equal to k. So half k is equal to m omega square, x square is equal to half m omega square, a square minus x square. Half omega square x square get cancelled. So here we have x square is equal to a square minus x square. 2x square is equal to a square, or root 2x is equal to a and plus minus a, and x is equal to plus minus a by root 2, and option C fits our answer. Moving to next question. A body is executing simple harmonic motion with frequency n. Then the frequency of potential energy we have to find out. So this can be solved using, because here we have SHM, so we will find the frequency using base equation of SHM. We will form equation for potential energy and then we will find out the frequency. So we know that x is given by amplitude into sine omega t. We are taking here a sine form, and omega is 2 pi by t, and that can be written as 2 pi into frequency t. So a sine 2 pi frequency into t. Here we have to find out frequency of potential energy, and we know potential energy is given by half kx square. So half k a square sine square 2 pi frequency t. Now what we do? Now to compare frequencies, we must convert this sine square into simple terms. Means we can convert into in cos or sine form. Why? Only then we will be able to compare the frequency. If we have to compare the phases, then both of them should be in the same form, and if we have to compare them in their frequency, then both of them should have the same power. Here sine have one power, here sine have square, so we have to remove this square, and we can remove it by using cos because we know conversion equation for sine square theta, that twice of sine square theta is equal to 1 minus cos 2 theta. Here we have theta 2 pi ft in terms in place of theta, so sine square 2 pi ft will be equal to 1 minus cos 4 pi ft, or sine square 2 pi ft is equal to 1 minus cos 4 pi ft divided by 2. So we will replace the value, substitute the value. K a square 1 minus cos 4 pi ft divided by 2. This can be written as 1 by 4 k a square 1 minus cos 2 pi into 2f t. Why we wrote this in this way? Because here we had 2 pi times frequency times into time, 2 pi multiply frequency multiply time, and here we can say 2 pi multiply new frequency or f dash into time. So here frequency of potential energy, that is f dash, that is equal to twice of the original frequency of displacement. So displacement have frequency f, then potential energy has frequency 2f, and here frequency is denoted using n. So our and the frequency of potential energy will be 2n. With n we have 2n. If it had 2n, then it should be have 4n. Moving to next question. A particle of mass m is released from the rest and follows a parabolic path as shown in the figure. Assuming the displacement of the mass from the origin is very small, which function correctly depicts position of the particle as a function of time? Now, as per mentioned that displacement is small, displacement from the origin is small, and if displacement from the origin is small, then it denotes that particle is having or executing simple harmonic motion. So we can either have sine curve or cosine curve as per displacement, means x can be either represented by a sine omega t, or x can be written as a cos omega t. And now graph for sine is something like this. So not like this, something like this, and for cosine it is something like this. So here option A does not satisfy both of these, B does not satisfy, so we have to find out between C and D. Now, as per mentioned that particle of mass released from rest and follows a parabolic path. So initially in starting particle was at this position. So from the origin it had already had some displacement, or we can say at t is equal to 0, particle was at, you can say, maximum position, and that is represented by cosine curve, because at time is equal to 0 only cosine curve give us displacement from the mean position, that is maximum at time is equal to 0. So C does not match, only option D matches, so option D will be the right answer. Next question. Particle executing SHM motion has a kinetic energy k node cos square omega t. Maximum value of potential energy and total energy are respectively. So here particle executing SHM, kinetic energy is given by this relation, maximum value of potential and kinetic energy respectively. We have to find out. So as you must be confused that what is this type of kinetic energy is given as kinetic energy is equal to k node cos square omega t. So it means that kinetic energy is variable, and its variation is given by cos square omega t. Now we can write it like this: k node cos omega t whole square. Now we know that maximum value, because we have to find out maximum value of potential and total energy. So maximum value of cos omega t is 1, or we can say maximum value of kinetic energy is given by k node. Maximum value of this is 1, so k node into 1 square is equal to k node. And we know for SHM, sum of kinetic plus potential is constant, and there are positions in certain conditions in SHM when kinetic energy is 0 and when potential energy is 0. When kinetic energy is 0, then kinetic energy is maximum, and when kinetic energy is 0, then potential energy is maximum. So When potential energy is zero, kinetic energy is maximum. Then maximum value of kinetic energy is K node. K node plus 0 is equal to total energy, and that is constant. So total energy is also K node. So max value of kinetic is K node. Max value of potential is also K node, because when potential energy is maximum, kinetic energy is zero. So 0 plus potential energy maximum is equal to total energy, and from this relation total energy is K node. So potential energy is also K node, maximum value potential energy, and total energy is also K node. So maximum value potential and total. So option C, K node and K node is the right answer. Moving to next question. A particle of mass m oscillate with SHM between x1 and x2. The equilibrium position being O. The potential energy is plotted as a function below the graph. So we have to find out the graph for potential energy, and we already know that for potential energy formula in SHM is half k x square. So when displacement is zero, potential energy is zero. When displacement is maximum, potential energy is maximum. And here you can see in graph B, when displacement is zero, then potential energy is maximum. So it is wrong. Here we have square relation. Both option C and option D don't have square relation. This is I think this is cosine relation or something, and this is straight line relation. So both of these are not right answer. Only option A fits properly. So option A is the right answer. Next question. The potential energy of SHM when particle is halfway from its endpoint. So particle is halfway, or we can say displacement is half of the amplitude, and we have to find its potential energy. So potential energy is given by half kx square. So potential energy is given by half k x square, or it will be equal to half k a square by 4. Now here answer is represented in terms of E, where E is the maximum energy, and maximum energy or total energy is equal to maximum potential energy, and that will be equal to half k. Potential energy will be maximum when displacement from the mean position is equal to amplitude. So amplitude is A, so potential energy maximum is half k a square, and that is equal to total energy. So we can write it like this: 1 by 4 into half k a square, and this can be written as E by 4. So option C fits perfectly. Moving to next question. Displacement between maximum potential energy position and the maximum kinetic energy position for a particle executing SHM is. So potential energy is maximum when displacement from mean position is plus minus a, because formula for potential energy is equal to half k x square. Now kinetic energy is maximum at center or at mean position. So when x is equal to 0. Why? Because formula for I can say kinetic energy is half mv square, where v is for v omega into a square minus x square. So a square minus x square. So when x is 0, kinetic energy is maximum. Now we have to find difference between both of these. X is equal to plus minus a and 0. So difference is again 0 minus plus minus a is plus minus a. So it is the answer option B. Next question. In SHM, restoring force is given by F is equal to minus kx, where k is the force constant, x is the displacement, a is the amplitude. Then total energy depends upon. So total energy for SHM is, we can say, potential energy formula is half k, And here we are discussing about total energy, and total energy is equal to maximum potential energy, and maximum potential energy is equal to half k a square, where A is amplitude. So maximum potential energy only depends upon value of k and value of a. So x is not there, so depends upon k and a only, and here it is. So option C is the right answer. Next question. In SHM, when displacement is one half of the amplitude, fraction of total energy is kinetic. So here it is given, displacement is one half. So x is equal to a by 2. And we have to find out here, you can say kinetic energy. So kinetic energy is given by half m into omega square a square minus x square. Substituting value of x is equal to a by 2, what we get? We get half m omega square a square minus a square by 4, that is 3a square by 4, and that is equal to 3 by 8 m omega square a square. Now total energy, we have to find that what fraction this kinetic energy is of total energy. Now total energy of a spring is sum of potential plus kinetic, and it is also equal to maximum potential energy, and it is also equal to maximum kinetic energy. So from this, maximum kinetic energy will be when x is equal to 0, and when x is 0, maximum kinetic energy or total energy will be equal to half m omega square into a square. So now kinetic energy by total energy will be, this m square omega square a square will get cancelled from both, and it will be 3 by 8 divided by 1 by 2. So answer will be 3 by 4. Option D is the right answer. Next question. Body execute SHM with amplitude A at what displacement from the mean position? Potential energy of a body is 1/4 of the total energy. So potential energy of body 1/4 of total energy. So again, total energy of body is equal to maximum potential energy, and that maximum potential energy is equal to half k a square, and now given is potential energy is 1/4 of total energy. So potential energy of body, there is a basic formula for that, and that is half k x square is equal to 1 by 4th of total energy, that is 1 by 2 k a square. So half k get cancelled, and from this x is equal to plus minus a by 2, or option B is the right answer. Next question. Angular velocity and the amplitude of SHM pendulum omega and a respectively, displacement x from the mean position. If kinetic energy is T and potential energy is U, then the ratio of T and U. So we have to find out ratio of T and U. Now again, kinetic energy is given by half m omega square a square minus x square, and potential energy is given by, when displacement is x, that is equal to half k x square. So ratio will be, we have to find ratio of kinetic to potential. So kinetic to potential will be, half will get cancelled, and we also know that k, we know that omega is under root k by m. So omega square m is equal to k. So k will get cancelled by m omega square. So we just have a square minus x square divided by x square, that is option C. Next question. If the mass of the bob in a simple pendulum is increased to thrice of original mass, and length is made half of the original length, the new time period of oscillation is 2 by x by 2 times of the original time period. Value of x. Now this is simple pendulum, not spring motion. For spring, omega is given by K by M, but not for uh, simple pendulum. For simple pendulum, we have a relation that time period is given by under root 2 pi into L by G, and here time period does not depend upon mass. It only depends upon length. So new length is made half. So T dash will be 2 pi into L by 2. G will stay as it is. So here 1 by under root 2, 1 by root 2 will come outside, and it will be 2 pi L by G. It is equal to original time period. So this will be T by root 2. It is T by root 2. So T dash by T is equal to 1 by root 2, and this 1 by root 2 is given equals to x by 2. So from this, x comes out to 2 by root 2, that is root 2. And here we have option A, that will be the right answer. So you have to distinguish between simple pendulum and SHM, that with spring and mass. For mass and spring, that we have time period equal to under root 2 pi M by K. For spring mass system, time period depends upon mass, but for pendulum system, time period only depends upon length from the top position to center of mass. Now moving to next question. A pendulum is hung from a roof of sufficiently high building and moving freely from to and fro like a simple harmonic oscillator. Acceleration of the bob of the pendulum is 20 meter per second square, distance 5 meter from the mean position, time period of the oscillator. So as it is mentioned that it is behaving like SHM, simple harmonic oscillator. So in that scenario, acceleration is given by negative omega square x, means acceleration is towards the mean position, where omega is 2 pi by t and x is the displacement from the mean position. So acceleration is given 20, and because it will be towards mean position, so we will take it is minus 20 minus omega is omega square as it is, and x is 5. So from this, 4 is equal to omega square and omega is equal to 2. Now omega is equal to 2 pi by t is equal to 2. 2 get cancelled, and from this t is equal to pi second, or option B. Let's move to next question, and this will be the last question for this video and this chapter also. Time period of a simple pendulum 2 seconds. If the length increase by 4 times, time period becomes, again it is simple pendulum, so time period is given by under root 2 pi L by G, and length is increased by 4 times, so new length is equal to 4L. This will be written as under root of 4 outside 2 pi L by G. Now this time period is 2 seconds, so this is also equal to 2 seconds. So root 4 is 2 into 2, it will become 4 seconds. So option D is the right answer here. So with this video ends here. Hopefully whatever we have discussed here is helpful to you and thought provoking. And if you have any doubts or suggestion, you can put them in comment section. I will try to implement or answer them. And again, if you like this video, hit the like button, share as much as possible, and subscribe to our channel. Also, if you want to support us financially, then you can scan any of these QR codes and donate us with whatever amount you want. It will help us in future to keep on making these videos and keep on continuing this series. So again, thanks for watching, and we will meet in next video.